Lutetia is a main belt asteroid, one of probably millions large and small, orbiting the Sun between Mars and Jupiter. Many are considered to have remained essentially unaltered since planets like ours were formed. Asteroids have been classed according to their size and probable composition. Although extensively studied since its discovery in 1852, Lutetia is still a subject of great debate and could prove to be an anomaly in present classifications. At first supposed to be an M-type asteroid with the presence of metals like nickel and iron, some data suggest that Lutetia should be classed as a C-type object containing primitive compounds of carbon. The measurements obtained during the flyby should hopefully settle this issue. The global density of the asteroid will be determined from a mass estimate and volume determination thanks to Rosetta's radio science experiment and OSIRIS camera. This camera already imaged the asteroid from a great distance in 2007, a small stationary dot 245 million kilometers away. Now the spacecraft will pass at a distance of only 3,200 kilometers. To assist the spacecraft navigators and scientists in planning the flyby and the sequence of Rosetta's observations, astronomers have used existing data to predict Lutetia's shape. Some astronomers still believe that it has a potato shape, like the Itokawa asteroid visited by Japan's Hayabusa probe, whose sample capsule returned recently to Earth. But most astronomers now believe it is more probably a squash-shaped object, resembling the diamond-like Steins asteroid, only 5 kilometers in size, and whose many impact craters Rosetta observed at close quarters in 2008. In effect, sophisticated models based on near-infrared images and light curves obtained by ground-based observatories predict that Lutetia has, continuing the culinary comparison, the shape of a wedge of camembert cheese, 120 by 100 by 80 kilometers in size. Most likely the asteroid revolves once every 8 hours, tilted some 5 degrees to its orbital plane, much like Uranus, implying strong seasonal effects on its surface. And so the flyby will only be able to observe the northern hemisphere. The models also suggest that Lutetia has several major concavities or craters near its north pole and around its equator. Keeping the asteroid in its field of view as it passes, Rosetta will be in constant contact with the ground, its signal being received by ESA and NASA deep space stations, principally NASA's 70-meter dish in Madrid. Information is expected for some 36 hours around the time of closest approach at 1544 Universal Time, 1744 in Central Europe. Taking 25 minutes to reach Earth, the raw data will then arrive at Rosetta's Mission Control Center in Darmstadt, Germany, where enthusiastic scientists will start processing the images to be made available in the following hours.
When is the earliest they can...
The probe will then pursue its odyssey towards the comet 67P Churyumov-Gerasimenko, which it will reach in 2014, and upon which it will place a lander. But for the moment, Rosetta's images of Lutetia, with its insights into the origins of the solar system, will be a major scientific prize for ESA's comet-chaser.